Okay, so I'm sitting at the breakfast table this morning, and I'm telling my wife, I says, "Yeah, honey, I'm sorry I was at work late last night because what I did was I did the project all in one sitting. I know the video was only 13 minutes, but it took me an hour and a half because you got to prepare and you make mistakes and you got to make sure that things are all right. You got to review, you got to edit, you got to upload, and do all that kind of stuff." So I was explaining to her the process that I was going through, that you know what the size of the objects are in real life, and then you pick something that is, you're going to start with, you're going to pick an object, and you're going to start with that object, so you know that object, say it's a softball, and you're going to compare that to the size of the real Earth, and with the size of the real object and then the size of the model object, you get a scale factor. With that scale factor, then you can determine the size of the other object, and you can determine the size of the distance in between those model objects, right? So once you get your scale factor, you work with that. And I explained to my wife, I said, I got down to the end of the video, and the numbers were such that the distance between the Earth and the Moon was over 5 meters. And I was really dramatic in the video, and I slapped my pen down on the paper, and I said, "Oh, I've got to go back to the drawing board and do this all over again," right? And my wife says, "Silly husband." She said, "Why didn't you just determine take your limiting factors to begin with and determine what the size of the largest object was that you could start with, and make sure that you didn't start with an object that was too big in the first place so you wouldn't have to go and redo all your work?" And I said, "Okay, wife, you're going to have to explain that to me. You understand, she's an engineer. She's way smarter than I am. She does less work but makes more money. I guess that's what happens when you're really smart, right?" She said, "You need to use the law of proportions." Hey, here's an idea. Why don't you kind of write what I write? This might help you out in your project. Law of proportions. Proportions, proportions. Uh-oh, I'm going to get in trouble for this. Pre-RO, proportions. All right, the law of proportions says that if you have, say, x over y, and that's a proportion, then you can, you've got a over b or something like that. And you've done this like probably a bazillion times in math class where you got to do this thing called cross multiply, right? All right, so let me set up a proportion that we're talking about with our project. So we said the scale factor is equal to the size of the real object divided by the size of the scale object. Okay, we're going to set that up as a proportion, because now we can say that the distance in the real world, running out of screen, is equal to the distance in the scale world. So this is the information we have to work with, right? These are just scale factors, right? Size in the real world, size in the scale world. Distance in the real world, distance in the scale world. Those are both equal to the scale factor. Scale factor is equal to scale factor. So this is all true statements so far. Now how does that help us not make a mistake that we have to go back to the drawing board for? She says, "Well, honey, you know that the distance in the scale world can be no larger than 5 meters. Right? And you know what the size of the real object is." I'm going to forget these, right? The size of the Earth is 12 point something million meters, right? So that's 1.2 times 10 to the 7. And the distance in the real world, oh my gosh, I'm going to have to edit this tape because I can't remember what the distance is in the real world. All right, there we go. Good, good. All right, Earth-Moon distance is 384 million meters. 384 million, that's times 10 to the 6, 7, 8. 3.84 times 10 to the 8. And then, all right, oh, look at this. We've got 3 out of 4 that we already know. We don't know what the maximum size of our object is. All right? So if we rearrange this equation, then we can say max object size, or in this case we're talking about the Earth, maximum scale Earth size is equal to, do your cross multiply, so we're going to say 1.2 times 10 to the 7th times 5 divided by 3.84 times 10 to the 8. Did I do that correctly? All right. Pause video. Everybody get out a calculator and you tell me. All right, the answer is 0.15 meter, also known as 15 centimeters. So you get out your ruler and you go over to the box of balls, and you find an object that's smaller than 15 centimeters. And if you do that, then you won't have to redo the report, right? Once you get all the way to the bottom, you need to make sure it fits in the classroom. And if you start out with your largest object smaller than 15 centimeters, you'll be in good shape. I just saved you a whole bunch of time, all right? Thank you. You're welcome.